Hey everyone. So today we are discussing the problem Leetcode 2163, minimum difference in sums after removal of elements. This is also Leetcode problem of the day for today. It is a hard problem, it from hard category, but we'll see it's not that hard. If you look it at the first glance, it might look a little confusing. So I would like you guys to just go through this question and just go through the example and just pause the video and resume when you are done looking at or just done wondering what we can do and just think about it for a while. Okay, so I think you have done that. I hope you have done that and just thought about it. I will try to explain the question to you now and we'll see how we can solve this problem. Okay, so it says that we will be given an array of size 3n. From that, we have to remove a subsequence, some elements of size n, such that the remaining 2n elements again makes an array, right? Such that the first half of the array, if we do the sum of it, and if we do the sum of the second half of the array, and we just do a difference of it, the difference should be minimum. Okay, so this is what is the problem statement. For example, let's take this example and try to understand 795813. Okay, I will quickly draw it over here and we will see. So the array says 795813. Okay, and if you just look at it, you will see that if you remove 9 from here and 1 from here, the resultant array that you are going to get is this, and the first half, the sum of the first half is, and the sum of the second half, whatever you will do, it is 7 plus 5 12 minus 11, and it is 1, which is minimum. Now if you just try to remove any other two random elements, and if you see, let's say we remove 5 and 8, so our resultant array will be 7913, right? The sum of the first half is 16 and the sum of the second half is 4, and the difference is 12, which is not minimum, right? And we have to find the minimum, so the answer is 1. And if someone asks what we have to remove, so we have to remove 9 and 1. Okay, so how to approach this problem, we will see. So just I will draw it real quick so that it remains in front of our eyes. 795813. If you just look at the problem, one thing you can just try to understand that if we just find a particular index, we can go to at any index and we can say that this index defines that my first half of the array will come from this and the second half will come from this. What I mean from that, so if you see 3n is the size of the array, right? We have to remove n elements, right? We have to remove n elements. So how many elements will stay? 2 cross n, right? So from wherever you remove the n elements, you know that there we can draw a line and you can say that the first half will belong to this and the second half can belong to this. We can keep the I as something different as well. For example, the same example 795813, we can say that I am drawing the line over here and the first half will come from here and the second half will come from here. Now if first half have to come from here, how many elements we have to remove? 2. And if the second half has to come from here, how many elements we have to remove? 0, right? Because the total size after deletion here, 2n, 3n is 6, so 2n will be 4. So we have to keep 2 elements at least over here. So here we will remove 0 elements, here we have to remove 2 elements, right? So what our funda should be, what our approach should be, that for every I, we will keep on increasing the I, and we will say that if till this element we have to keep the this as the first half and the next as the second half, what can we do, right? How many elements and how the elements should be removed. Now we are removing our problem, we are twisting our problem from saying what are we removing, we are removing that and we are saying that we will reread the problem as what we are keeping. So if you see 7, 9, 5, 8, 1, 3, we will say that at any index, if we are at here, let's say, since we have to keep two elements over here, so it and two elements over here. So if you see, and we have to do sum of first minus sum of second, and that should be minimum. So if you see how to do that, so if you see from any partition, if we keep this sum as minimum, right, and this sum as maximum, we can achieve this thing, right? So I'm saying the second part should be as big as possible, the first half should be as small as possible, and we can achieve this. And how to achieve that? To achieve that, to keep, and we know that how many elements we have to keep from here. We have to keep as the, like, since 3n is the size of the element, the first half should be of size n. In this example, n equals to 2. So from here, if we keep a heap of size 2, and we just keep a track of all the minimum elements of that in the heap, so 7 will go to the heap, 9 will go to the heap, 5 will go to the heap, we'll keep the heap size as 2 and we'll remove 9, and we'll keep a track of the lowest size. Here 12 will come. Similarly, here if we keep a size, the heap of size 2, but here if we keep it as the smallest, like 1 should go here, 3 should go here, 8 will come here. Let's say we are traversing from right to left, so 8 we will remove since the size should be 2, and we can say that since this we have to keep a maximum, so rather than removing 8 we should remove 1, and we can say that the sum of 3 and 8 is 11, so the difference of 11 minus 12 minus 11 will be 1, which will be our answer, right? So one thing we know that what we can do, we can use two different maxip and minhip over here and get the minimum for every index from the left and for the right, and we can say that this is our answer, and this can be one of the potential answers. But how to do that? If you see, if we are let's say traversing from left to right, it is very easy to keep a track of all the heap elements. We can just keep on adding it to our this heap, and as soon as the size grows more than n, we will remove the biggest element so that we can have all the small elements, and we can say that this is our answer. But as we grow here, this becomes a problem here, and we might need to build the heap again and again in this part, right? So here, that's why this problem becomes a DP problem, and we can use a concept of DP. We can use prefix array over here, okay, prefix array over here, and we will use the heap, and we will solve this problem. So this problem is a combination of prefix array and the heap. So whatever we discussed that what will be the sum of whatever will be the sum of maximum sum that we will get from here, rather than keeping it in the heap and removing it, we will store it in a different array, and we will store it, and then we will start processing it. Okay, cool. Now before jumping to the code, I will just try to explain you one more part. Okay, for let's take this example only, and then we will see how this can be extended to all the other examples. So if you see, this is the 6 part array, right? Now let me take a 9 length array, 1 2 3 4 5 6 7 8 and 9. Now you know that here 3n is 9, so how many elements should be removed? 3 elements should be removed. Those 3 elements can be from anywhere, and the remaining 6 elements, it will be broken into 3 part and 3 part, right? So now if you just see that we have to keep at least we should start our iteration from this part, and we should stop our iteration at this part, or I can say this part, basically this part, including this if we are taking that, right? So what I am saying that my I, if it starts from here, what I am saying that I am saying that 3 elements at least should be in the first part. Why? Because my element is, my array becomes n plus n plus n, and since we are removing n, so at least n should be at the left part and n should be at the right part. right? So if I start my iteration from I, I can't say that I can have more than three elements from here, right? I can have three elements from here. If you just I start my I from here, so I have to give two, at least these two elements to the first part, and these all will go to the second part, which is not possible, right? We have to at least keep these three in our first heap and these three in our last heap, and we can start iterating over here. And actually from here, and we can say that including like including this three, how many elements from here we can get, including this 4, 1 2 3 4, how many elements can we get from here, including this 5, how can we achieve that, till 6, how can we achieve that, but we can't reach till 7. Why we can't reach till 7? Because as soon as we keep 7 in this part, this first half, the second half will be reduced to only 2 elements, right? But we know that the first half and the second half, so it should be at least 3. Okay, it should be at least 3. So our iteration should go from 3 to 7. Okay, let's try writing the code, and meanwhile you will understand it a little better how and what we are doing. Okay, so let's try to write this. So what we can do to solve this basically is we can first say that here the size is, let's say, whatever the variable was, we will keep it as lambs of this divided by 3. Okay, now let's initialize a few variables called left minimum. We know that we have to keep a minimum in the left and we have to keep a minimum in the right, maximum to the right, right? So left minimum, the other which I want to define is right maximum, and I will initialize it with 0, and we can let's keep a answer which we have to minimize, and I will initialize it with long dot max value, and then we'll minimize this. Okay, now we should have some extra space for our basically the prefix array. So I am creating a temp prefix array of size. We don't need actually for this size, as we discussed the first part, and we are introducing from this to this. So if you see, the size of my prefix array does not require to be more than n plus 1. Why? So 1 to 9 it was there, and since we can start from 3 and just go till 6, so if we keep the size of the prefix array as n plus 1, that will be enough. We will see how it is actually working. Okay, now let's initialize the priority queue of integer, and we can say that my left priority queue, it will be there such that, and it will have new, I will just say new priority queue, okay, where we'll be keeping integer itself. And what I am saying that we will keep it in the reverse order. Okay, why, I will talk about it. So it is this, since we, as we discussed that if we keep on keeping this of the priority queue, left priority queue of size n, and we keep on removing the biggest element, so at any point we will have only the smallest element in the left queue, and we can keep the minimized sum. But this case is reverse for the right part, right? I hope you know. So this, my right priority queue will be same like this, but in the reverse order, but with the reverse order, so I don't need to make this. Okay, now what I will do some pre-processing for the left array. So I will start from the 0th index, I will go to the nth part. Why nth part? From 1 to n only I just want to go. And what I want to do, I want to say that in my left PQ, I should add the integer, and I should add it in my left minimum variable as well. Okay, so this is what we will do for the left priority queue. Now we should do something for the processing of the right priority queue. So what I will do, I will start from the backward. So I will do this nums dot length minus 1, and I can say that till this is my equals to n element. So I am saying till this whole thing is becoming till 4, which is nth element. What I will do, I will keep on doing this iteration, right? Why do we need to that iteration? Because the second part cannot exceed more than this 4. The second part cannot exceed more than this 4, right? So that's why I will stop at I equals to n, and what I will do in this thing, that I will add this in the priority queue. First of all, this nums of I, and I will increase the right maximum value. Just pay some attention over here what is going to happen. Okay, now if you see here, we just added n elements only, and we want our array to this left priority queue to have size n only. So this is not an issue, but this actually is running from length minus 1 to n. So from length minus 1 to n, so it is actually running for 2n size, right? So we have to add a check over here that if my right priority queue and the size of this becomes greater than n, so we have to remove the smaller elements, right? We should remove the smaller elements. So how we will do that? It will be on our top only. So if we just do minus equals to, first we will, let's say, peak it, so that we just remove that from our right maximum as well, and then we will just poll it. Okay. There can be other ways also, like we first directly poll it and store in other variable and do, but that's not the problem of our discussion. We can write it in any ways. Okay, so if this is the case, then we'll do write that. Okay, now as we discussed, till here everything is fine. This iteration is going from backwards from here to this part. But we know that for this part from 3 to 6, we need to store this in a prefix array, so that when the actual iteration will start from left to right, we will have all these values in a prefix array already saved. So what I will do, I will just add another statement here, and I will say that if my index is n, or we can say is between end or 2 into n, if this is lying between this and this right now, what I will do, I will start storing the values. We can start storing the values as, I can say that since my variable name was temp, so I can say temp of I minus n, it should go as, we can say, right maximum. Okay, so whatever these value will be, so it will start from I equals to n till there. So I am saying that whatever this value is, whatever the right maximum that we calculated, we will store over here. And now what I can do is, this our whole prefix array is now calculated. Okay, now what we have to do, now we have to do the actual calculation. So what we can do, we can start another iteration from, let's say we will start from I equals to n, which was here, I equals to n, and then I can say I less than, we should reach it till 2 of n, right? From n to 2 of n we will go, and for each of them what we will do, we have to do one thing. Okay, one more thing. So we have to first initialize, we can initialize the answer as, first of all my answer can be left minimum minus temp of 0. What does this mean? This means that left minimum, let's say for this example, 795813, 795813, if I have run from 0 to 2 only, what will be my left minimum? My left minimum will already be 16. For now it is 16. And how will my temp array look like? My temp array will look something like, it will be of size 3. Okay, it will be of size 3, and what it is saying that my temp of 0, if you see temp of I, so as soon as this temp of 2 into n will come, it will say that the maximum it will be the right maximum, whatever we have discussed. So for let's say I equals to 2 into n. So here n is 2, right? So 2n is 4. So as soon as my index is 4, 0, 1, 2, 3, 4, whenever this index will come, what we are saying that for I equals to 4, the right maximum, what is the right maximum that we are calculating? So the right maximum, we started from here, and we have added 3 plus 1, 4. So we have added 4 over here. Okay. Then again, what is the right maximum when we reached over here? When we reached over 8, we know what will happen. This size is greater than 2, so something will be removed, and the value of this will become 11. And when if I reach my I till here, it will say that again this 2 value will be removed, and it will become the other minimum, which was 3, it was removed, right? So 8 plus 5, it becomes 13. Okay, so it became 13. Now, so what it means, that now this is my temp array. This is my temp array. Now if you see this 16 and 13, it means that if we take two elements from here, and if we remove the two elements, which is 1 and 3, we will get the difference as 16 minus 13, 3, right? Okay, fair enough. Now if we keep our iteration till here, what we can say, that my left minimum will be updated with, if you see what I will do, I will start from n, I equals to n here, and I can say that I will push this in my priority queue, nums of I, and I will say that I know that my left priority queue has size n only, and now we have increased this. So without doing anything, we can say that we can add this new number to our left minimum. Then do a very careful thing. Then we know that the size of my this will be n plus 1, and now we know that if we just do left pq dot pop, it will remove the biggest element. So it will remove the biggest element, and my left will be again minimum. Then what I can do, I can say that now my answer can be minimum of this answer, or left minimum minus, you can say that we have to remove something from the array. What we are removing from this array? Temp of, if we are at index 5, what we are removing? Temp of this. So which is, if you see, it is basically I minus n plus 1. Just pause the video and think how it is I minus n plus 1. Here the value of I, let's say at 5, the value of I at 5 became as I equals to 2, right? N was 2. So what is I minus n plus 1 over here? 2 minus 2 plus 1, which is 1. So for this, the sum was the minimum of this. What is the minimum of this? 7 plus 5, 12. And since this value came as 1, temp of 11, which is 11, so the sum became 1. So this is this. Now after doing all this, if we just return answer, this should return. Let's see if this code works. There is a compilation error over somewhere. Reverse order is not there. Left dot pop is there. I'm sorry. Left dot pop is there. Line 36. Okay, let's see. We will resolve one by one. So priority integer, left priority queue we did. Reverse order we did. So what can be the issue if we just do reverse order? Collections. This is the issue. Collections. Okay. What's the other issue? At line 36. it is saying that left dot pop. Okay, so if this is the issue, actually it should be pole. So let's do the pole. Pop is actually in C++. And there is an index out of bound minimum difference at line this. Okay, let's try to resolve this and we will see what could have gone wrong. So when if I am running from I equals to n to I equals to 2 of n over here and left of this and temp of I minus n plus 1 if we are removing from this and it came from this solution dot min difference. Okay, it's coming somewhere over here if I am running from I equals to n and this. So I equals to this and we are running till I greater than or equals to n. So num of I, oh, I'm sorry, I should have reduced this value from I minus minus. Okay. Okay. So this is now running. Now let's try to submit this. Okay, it got accepted. Cool. So this was the problem. It is a combination of prefix, array, and heap, and this is how we can solve this. If there are related questions, you can solve it similarly. So thank you, everyone.